Good
Hello,
morning,
everyone.
everyone.
Welcome
Well,
to. Go ahead.
sorry about that. Good morning, everyone. Welcome to the TVE Happy Math Hour, our weekly interactive and reviews for Math 1314 and Math 1324, presented by Ms. Yvette Chuca, Mr. Ruben Carizales, and Mr. Albert Isasi. This session will be recorded so that you may come back to it later if you need, and so others may have missed out on today's events will be able to come and watch it. This event will provide Tejano Passport points. This code will be posted on the chat at the end of the session for the Tejano Passport points. Briefly, we'll be sharing the link to 1324. So if anyone's interested in joining that, we'll do so by providing the link. So now at this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with the information we'll be sharing today. Without further ado, I'll turn it over to Ms. Yvette Chuca.
Hello, everyone. Welcome back from spring break. Hope everybody had an awesome week. And so for today's session, we're going to be covering some problems for exam 2 review. And so these are the sections 2.1 to 2.6. And we'll start with 2.6 first. So in 2.6, we have the rational functions. And in this problem, they want us to do all these different steps. So the first one is to state the domain of the function. And so just to start with each part, when we're looking at the domain, we want to check if if it has a fraction and if the denominator has a variable, then we know that there's going to be some exceptions. And so those are the ones that we want to not include, or we want to exclude them from the domain. So to do that, we can set the denominator equal to 0 and solve for x. And so here we would get x is equal to -3. So what this means is that the domain is all real numbers except for x equals -3. And so we would exclude that from our domain. So if we look at our possible answers here, then it would be the last one, all real numbers except x equals -3. So let's go to B. For B, it says identify all intercepts. And the first one is the x-intercept. Remember that to find the x-intercept, we let y equal to 0 and solve for x. And so if we want to do that, then we set f of x equal to 0. And then we're going to go ahead and multiply by x plus 3 on both sides. And we end up with 0 equals to 1, which is a false statement. So what this means is that there's no x-intercept. For the y-intercept, we let x equal 0 and solve for y. So we replace x with 0. And if we simplify, we end up with 1/3. So my y-intercept is 0 and 1/3. So that's step B. For step C, we want to find any vertical and horizontal asymptotes. And so I'll go over each one first. So to find the vertical asymptotes, these are the steps here. First, you want to make sure that you factor the numerator and denominator completely and cancel any like terms or any like factors. Then we're going to set the denominator equal to 0 and solve for the variable. And then when we find that asymptote, we graph it with a dotted line. If you happen to cancel any factors in step 1, then that's going to create a hole in the graph. So here we check the numerator and the denominator. They're both factored already. So there's nothing to do there. Then we're going to set the denominator equal to 0 and solve for x. And so we get x is -3, which is going to be our vertical asymptote. So when we graph it, we use a dotted line. Now let's look at the horizontal asymptote. So for horizontal asymptotes, there's 3 possible cases. The first case is when the degree of the numerator is less than the degree of the denominator. Then we say there is an asymptote at y equals 0. The second case is when the degrees are both the same. Then we say that the horizontal asymptote is going to be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. And then the third case is when the degree of the numerator is greater than the degree of the denominator. If that happens, then there's no horizontal asymptote. But if the degree of the numerator is 1 more than the degree of the denominator, then it does have a slant asymptote. So for this problem, we check the degree. So the degree of the numerator is 0 and the degree of the denominator is 1. So that means that the degree of the numerator is less than the degree of the denominator. So the horizontal asymptote would be at y equals 0, which is the x-axis. Okay, so let's go ahead and gather all of the stuff that we've done so far. So the x-intercept did not exist. We have our y-intercept, our vertical asymptote, our horizontal asymptote. And then the last step is we're going to plot additional points. But you want to do that after we have plotted everything else. So here's my vertical asymptote. Here's my y-intercept. And the horizontal asymptote is the x-axis. So it's just right here. And so I want to make sure that the additional points, I pick some on the right side of the asymptote and then some on the left side. So if I pick -2, then I would end up with 1. If I pick +2, I end up with 1/5. And on the left side, if I pick -4, I end up with -1. And -5 will give me -1/2. So if I plot these points, then this is what they look like. And so if I connect the points, then my graph is going to look like this. So the graph gets closer and closer to that asymptote, but it's not going to touch it. And then it does the same for the x-axis. So those are the steps for graphing a rational function. Let's consider the following, another example. So same idea, we want to do all these steps here. So to find the domain, we have a fraction. It has a variable in the denominator. So we're going to set that denominator equal to 0 and solve for x. So we get x equals -3. It cannot be part of the domain. So we're going to exclude it from the domain. So in this case, our domain is going to be all real numbers except for -3. So that's going to be the second option. Okay. Next, we find the y-intercept. So we set c of x equal to 0. We're going to multiply by x plus 3 on both sides. So we get 0 times x plus 3. The x plus 3's will cancel. And then solve for x. So we subtract -2 and divide by 3. So x is -2/3. That's going to be our x-intercept. Now for the y-intercept, we want to do the same thing. We're going to let x equal 0. And then from there, we're going to solve for y. Okay, so we input 0 for all the x's, simplify, and we get 2/3. So my y-intercept is going to be y. This should be a y. Y equals 2/3. Then for the asymptotes, we want to make sure that we factor. These are both factored already, so there's nothing to do there. Set the denominator equal to 0, and then solve for x. So our x equals -3 is our vertical asymptote. And then our horizontal asymptote, the degree of the numerator is 1. The degree of the denominator is 1, so they're equal. That means that our horizontal asymptote is going to be the leading coefficient, which is 3, divided by the leading coefficient of the denominator, which is 1. So y equals 3 is our horizontal asymptote. So this is all the information that we have. And so if we plot that information, here's my vertical asymptote, my horizontal asymptote, my x-intercept, and my y-intercept. And for some of us, this might be, those 2 points might be enough to graph it, but to be sure, we can use additional points. So again, the suggestion is to do some on the right side and some on the left side. So if I pick -2, I get -4. If I pick 2, I get 8/5. If I pick -4 on the left side, I get 10, and -5 gives me 13/2. So if we plot the points, then we end up with this graph. Okay, if you have any questions, just let me know, or you can put it in the chat. I think I have one more. Okay, so let's look at x squared minus 9 divided by x. So if we set the denominator equal to 0, then we get x equals 0 is excluded from the domain. So this is going to be all real numbers except for 0. X-intercept, we're going to let y equal 0 and solve for x. So if we multiply by x on both sides, we end up with 0 equals x squared minus 9. Add 9 on both sides, and then take the square root. So we end up with x equals plus or minus 3. So these are our x-intercepts. And then for the y-intercept, we're going to let y equal 0. So if I input 0 here and 0 here, then I cannot divide by 0. So that means that we have no y-intercept. That does not exist. Okay, so let's try the asymptotes. So for the asymptotes, we want to make sure that that we factor if we can. So here we have x squared minus 9 would be x minus 3, x plus 3, and then divided by x. I cannot cancel any of them, so we move on. If you were able to cancel, it would look something like this. You would have down here, for example, an x plus 3. And then you would be able to cancel this factor with this factor. And so this factor with this factor. Okay, so that's what I mean by canceling. So since we can do that though, we take our x, set it equal to 0. So that's going to be our vertical asymptote. And then the next one, the degree of the numerator is 2 and the degree of the denominator is 1. That means that the degree of the numerator is greater than the degree of the denominator. So there's no horizontal asymptote, but we got to check if there's a slant asymptote. So the question is the degree only one more than the degree of the denominator? And it is. Therefore, we're going to have a slant asymptote. To find the slant asymptote, we can use synthetic division. And so remember for synthetic division, let me just write here. If our divisor is x minus some number, then the c is what we use in here. But since I don't have a c, then we're using 0. Then x squared is coefficient is 1. There's no x, so we have 0. And then our negative 9. So we use synthetic division. We bring down the 1 times 0 is 0, plus 0 is 0. 0 times 0 is 0. And negative 9 plus 0 is negative 9. So the quotient is going to be x. This is negative 9 is your remainder. So x is your quotient. And that's what's going to be your slant asymptote. And we write it as y equals x. Okay, so this is all the information we have. So here's my slant asymptote. And my x-intercept and my y-intercept is down here. So I have two x-intercepts. Pick some additional points. So I chose 2. I get negative 5 halves. If I use 4, I get 7 fourths. Negative 2 gives me negative 5 halves, and negative 4 gives me 7 fourths. So if I plot these and connect the dots, then my graph will look something like this. And notice that your vertical asymptote was at x equals 0, and that's why the graph is getting closer and closer and closer to this y equals 0 to the y-axis. Okay, so these were all questions from 2 points. Now we're going to go back to 2.1. It says write the quadratic function in standard form and identify the vertex axis of symmetry. So here I like to first separate the two terms with x's, and then I leave the constant outside. I want to make sure that in front of x squared is a 1. In this case, I have a 2, so I'm going to factor it out. And so if I factor it out, I get 2x squared plus 4x. Okay, so now what we're going to do is take half of 4 and we're going to square it. So half of 4, so 4 divided by 2 is 2. Squared is going to be 4. Okay, so again, half of 4 is 2. If you square that, you get a 4. So we're going to add plus 4 and subtract 4 in the parentheses. Notice that we're just adding 0. And then we're going to go ahead and remove that negative 4. But in order for me to remove it out of the parentheses, I have to multiply it times the number in front of the parentheses. So 2 times negative 4 would be negative 8. And then if I simplify further, x squared plus 4x plus 4 can be factored as x plus 2. Negative 8 plus 7 is negative 1. Since I have 2 of the same factors, I can rewrite as x plus 2 squared. So now this is in standard form, and I can identify my vertex, which is this number here. So it would be negative 2 and negative 1. The axis of symmetry is always your x-coordinate for the vertex, in this case, negative 2. The next one, find the real zeros and determine the multiplicity of each. So I always tell my students, the first thing is they tell you to find the zeros, so we should let f of x equal to 0. And so here I have 0. Then you want to ask yourself, if we look at each term here, is there anything that in common that we can factor out? So they all have at least a t squared. So I can factor out a t squared. So t squared times t squared is t to the 4th. T squared times t is t cubed. And t squared times 30 is negative 30t squared. Notice what is left in here is quadratic. So we can try to either factor. If you're not able to factor, then you can use a quadratic formula. So this factors as t minus 6 times t plus 5. I can set each factor to 0. So 0 equals t squared, 0 equals t minus 6, 0 equals t plus 5. So we get t equals 0, t equals 6, and t equals negative 5. The degree is 4, so that means we should have 4 zeros. I only see 3, but remember that when we have the t squared equals 0 for this one, that's the same as saying t times t equals 0. So if we set to 0, we get t equals 0 and t equals 0. So that means that the 0 is appearing twice. Okay, since the 0 appears twice, which is an even multiplicity, then it's going to touch and turn at x equals 0. At t equals 6, it occurs once, which is an odd occurrence. So that's going to cross the x-axis, and the same for negative 5. So the multiplicity of 6 and negative 5 is 1. It doesn't ask us to graph it, but if you were to graph it, notice here that at 6 it's crossing, and at let me see, this was negative 5, it's crossing, and 6 is crossing, and then at 0 it's going to touch and turn. Okay, so that's why the multiplicity is important for us to know, so we can know if it touches or if it crosses. Just review the end behavior, which is a leading coefficient test. I usually use these 4 pictures. Right now, hopefully you already know what these 4 graphs look like. But for x squared, notice that it has an even degree with a positive leading coefficient. If that's the case, it's going to rise to the right, rise to the left. If it has an even degree with a negative coefficient, it's going to fall to the left and fall to the right. If it has an odd degree with a positive, it rises right, falls left. And if it has an odd degree with a negative leading coefficient, it rises left and falls right. So for example, here, my degree is 3. So that means that it's an odd degree. So my choices are either this one or this one. And my coefficient is positive. So that means that the behavior is going to behave like this graph here, like x cubed. So we say that it rises right and falls left. For multiplicity, I use the same idea here. If your 0 is appearing twice, it's going to touch and turn. Here, the 0 appears 3 times, so that's an odd multiplicity, and it's going to cross, and it's going to cross. It looks like it touches, but it crosses right at 0. The possible rational zero theorem test is helpful to help us find possible zeros. And so in order to do that, we need the factors of the constant and the factors of the leading coefficient. So it says find the rational zeros. So if the first thing to do is use the rational zero test so that we can make our list shorter. So the factors of 9 are 1, 3, and 9. And the factor of 1 is 1. So if I write these, divide them, I have plus 1 plus 3 plus or minus 9 divided by plus or minus 1. So 1 divided by 1 is 1, 3 divided by 1 is 3, and 9 divided by 1 is 9. And so these would be our zeros. In WebAssign, you don't have this symbol, so you would have to list them from smallest to greatest. So now our list is pretty small. We have 6 numbers, 6 possible zeros. So I always suggest you start with 1 and use synthetic division. So if we do synthetic division, then we can see that 1 is going to give us negative 16. So 1 is not a 0 because we don't get 0 remainder. So from there, I suggest we use negative 1. And if we do synthetic division again, then we end up with 0, which is good because that means that negative 1 is a 0. And from there, it makes it easier because all we have to do now is take the quotient. So the quotient here is x squared minus 9. Set the quotient equal to 0. So I'm going to add 9 on both sides, take the square root, and we get plus or minus 3. I have a degree of 3, so I should have 3 zeros. And my zeros are 3, negative 3, and negative 1. And then the factors, need to write the factor. We're really taking negative 1 to the left side. So we're adding 1 on both sides, and we end up with x plus 1, x plus 3, and x minus 3. Okay, so let's look at this problem. It says to graph it. So the first thing is look for the possible zeros. So the possible zeros here, your constant, notice that we don't have a constant. It's 0. So we have the factors of that is 0 divided by the factors of your leading coefficient, which is 1. Then we just get 0. So that's my only possible 0 that comes from that rational zero test. So I'm going to go ahead and use it. So I have my 0 here. I have a 1 for x to the 4th, a negative 1 for x cubed, negative 6 for x squared, 0 for x, and 0 for my constant. So if I use synthetic division, I end up with this. Let's get the quotient. I get x cubed minus x squared minus 6x. Notice this is a cube. So at this point, you really could factor out an x from here, or you can repeat the process. So I'm going to go ahead and repeat the process. So I have 1, negative 6. Bring down the 1, and I end up with x squared minus x minus 6. You would have ended up with this if you just factored out an x at the beginning. So either way is fine. The good thing is this is quadratic, and so now I have choices. I can factor, or I can use the quadratic formula. So this example does factor, but I went ahead and illustrated with the quadratic formula. That way we can see an example of that. So B is negative 1, A is 1, and C is negative 6. So my zeros are x equals 3 and x equals negative 2. I should have 4 zeros. So I have negative 2, 0, and 3. But my 0, we were able to use it twice, once right here and once right here. So that means it has a multiplicity of 2, which is even. And so I've listed here that this is going to touch and turn for 0. This one's going to cross, and this one's going to cross. The turning points is the degree minus 1. So we have 3 possible turning points. So the first thing you want to do is plot your zeros. And then apply the behavior. So this is positive, or this is an even degree with a positive number. That means that the graph should rise to the right, rise to the left. At x equals 3 and at x equals -2, the graph is going to cross. So that's why I extended my graph going down. And now I need to fill in the gaps. So to do that, we can pick some points. So -1, if I enter -1, I get -4. If I use +1, I get 6, -6. And +2 will give me -16. So if I connect the dots, then I would go down. When I get to 0, it touches and it turns. And that would be our graph. Okay, so this is my sketch. I would do this on paper first. And then some of the problems on WebAssign are multiple choice. So then you can match it with your sketch. Okay. The next problem is finding the polynomial. And so we want to find the polynomial. And to do that, give me a second. We're going to need to find the factors. So they tell me that I have a 0 of x equals -4, 1 at x equals 1, and 1 at x equals I. And then since this is imaginary, the conjugate is also a 0. So that's why we have x equals -1 will also be a 0. The factors, x equals -4 will have a factor of x plus 4, x minus 1, and so on. So we're going to write it as a polynomial. F of x equals some leading coefficient, which we don't know what it is. And then I have my factors. So we want to multiply these out. I recommend that you multiply the imaginary factors first. So x times x is x squared, x times I is ix, negative I times x is negative ix, negative I times I is negative I squared. Simplify. Your ix's will cancel. So we're left with x squared minus I. I know that I squared is -1. So if I substitute that in, then I end up with x squared plus 1. So now we just multiply again. So x times x squared is x cubed. X times 1 is x. -1 times x squared is -1. And then we're going to go ahead and keep multiplying. So x times x cubed, x to the 4th, x times x, x squared, x times -x squared, -x cubed, and x times -1 is -x. 4 times x cubed, 4 times x, 4 times -x squared, and 4 times -1. So we gather our like terms, and we end up with x to the 4th plus 3x cubed minus 3x squared plus 3x minus 4. And then we're going to take our solution point. So f of 0 equals -8. This tells me that x is 0 and y is -8. So I have -8. I enter 0 for all my x's. And I end up with -4, divide by -4. So an is equal to 2. So if I plug that in, it's going to look like this. I'm going to distribute it into the parentheses. So we get 2x to the 4th plus 6x cubed minus 6x squared plus 6x minus 8. And that would be our polynomial. Okay, the next example is similar. They want us to use the given 0 to find all the zeros. So they tell me that 4 plus 2i is a 0. So I'm just going to use synthetic division. X cubed, I have a 1. X squared, I have a -12. X is 52. And 80 is my constant. So I'm bring down my 1. And then 4 times 1 is 4. 2i times 1 is 2i. -12 plus 4 is -8 plus 2i. So now we're going to multiply this factor times this. So 4 times -8 negative 32, 4 times 2i, 8i, 2i times negative 8, negative 16i, and 2i times 2i is 4i squared. Let's simplify in here. In other words, 8i minus 16i is negative 8i, and I squared is negative 1 times 4 is negative 4, and then we're going to add it to the 32. Okay, so negative 32 minus 4. Let me go back. So just to do this again, 8i minus 16i, negative 8i, and then this would be a negative 4. And then negative 32 minus 4, negative 36 minus 8i. Add the 52 plus negative 36 gives me a 16 minus 8i. So now we do the same process. 4 times 16, 64. 4 times negative 8i, negative 32i. 2i times 16, 32i. 2i times negative 8, negative 16i squared. My 32i and my negative 32i become 0. I squared is negative 1 times a negative 16 is positive 16. So we end up with 64 plus 16, which is 80, and then we get 0. So if you don't get 0 here, then we know we did something wrong. We have to get 0 because they already tell us that this is a 0. So your remainder should be 0. Our quotient would be x squared plus negative 8 plus 2ix plus our constant, 16 minus 8i. So you might be thinking, well, that doesn't look any simpler, but what else do we know about this problem? Since this is 4 plus 2i is a 0 and it's imaginary, we also know that the conjugate is also going to be imaginary. So 4 minus 2i will be imaginary. So I use the synthetic division again. So we have 1, negative 8 plus 2i, and 16 minus 8. Bring down the 1. Negative 8 plus 4 is negative 4. The i's cancel. And then we multiply and we get 0 again. So my quotient is x minus 4. Set it equal to 0. So we get 4. The degree is 3. We should have 3 zeros, which are x equals 0. I'm sorry, this should be x equals 4. And then we have our 4 plus 2i and our 4 minus I. So let me just correct this. This should be 4. Okay, so that's how we would find that polynomial. And so that was the last slide that we have. If you want to download this file, there's a box here where my mouse is pointing, with a box with an arrow pointing down. If you click on that, it allows you to download the PowerPoint. And then, of course, they have been sharing our YouTube links. You can go back and review this video if you like. But that is all I have for you guys today. Good luck to all of you on your exams. I know some of you are taking it next week, so good luck on that.
Thank you so much, Ms. Chuka, for your wonderful presentation. Again, we want to remind you guys about the downloaded, how you can download a presentation. You can go to the top right corner and click on the box with the little arrow pointing down while the presentation is on the screen. We do want to remind you guys again about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked was a short survey to help us improve our TVE sessions. Please take a few minutes to fill that out. And before you all leave, I want to share the TVE sessions that we will have next. At 1 p.m. today, we will have a presentation from the Mexican American Cultural Center, and we will be back with Happy Math Hour next week at 11 a.m., where Math 1314 will cover exponential and logarithmic functions, and Math 1324 will cover system of equations. Our 1 p.m. session next week will be a presentation on origami. Thank you all for coming in today. We hope you all have a lovely weekend, and if you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.